Okay, let's look at another example where we're solving for a concentration at equilibrium using an equilibrium table. This is an example where we do have to use the quadratic formula. So let's look at this one. So here's the problem. It says dinitrogen tetraoxide decomposes to nitrogen dioxide, and this is the equation. I'm just going to write out the equation just to save time because this will take a lot of calculations. So dinitrogen tetraoxide is going to decompose into nitrogen dioxide. And again, you always need to make sure that your equation is balanced. This is not balanced. I need a 2 here. Okay, so there's the reaction. The problem says at 100 degrees Celsius, the Kc equals 0.36. Okay, and then the question says, I'll just write it over here. If a 1.00 liter flask initially contains 0.100 molar dinitrogen tetraoxide, what will be the equilibrium concentration of nitrogen dioxide? So essentially we're using the Kc to solve for X, which we can use to solve for the concentration of nitrogen dioxide at equilibrium. So again, let's make our equilibrium table. Here is my reaction, initial, change, equilibrium. So it says the initial concentration of the dinitrogen tetraoxide is 0.100 molar. We don't start with any product. Here the change, minus X plus 2X. Don't forget this. A lot of people will forget this. This is where you will make the most mistakes in your calculations, is you will not remember to use the coefficient as the change. That, and also not remember to use the coefficient as the exponent. So then we're going to write the equilibrium concentrations, 0.100 minus X, and then 2X. So now this line right here is what we use for the Kc, because remember what the Kc is. The Kc is the concentration of the products over the concentration of the reactants at equilibrium. So I'm going to go ahead and write that out. I'm going to write 0.36 equals the concentration of the products, which is, I'm just going to write it out with the compounds first, and then we'll put the actual numbers in. Nitrogen dioxide squared over the concentration of dinitrogen tetraoxide. So now we know what these are, we can plug them in. So I'm going to say 0.36 equals the concentration of nitrogen dioxide, 2X squared over the concentration of dinitrogen tetraoxide, 0.100 minus X. And now I need to solve for X. So this is a situation where we cannot just take the square root of both sides to get rid of this X squared, because this term on the bottom is not squared. So this is the difference between the previous example that we did that was a perfect square. The top and the bottom were both squared, so I could just take the square root of this whole thing. The bottom part here is not squared, so I cannot. So if it is not a perfect square, this means you must use the quadratic to solve for X. And to use the quadratic, we need to convert this into the quadratic formula form, ax squared plus bx plus c. equals 0. Once it is in ax squared plus bx plus c form, then we'll use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. We'll get to that in a second. So first things first, let's convert this into ax squared plus bx plus c. So first thing I'm going to do is I'm just going to square this top part. So I'm going to get 0.36 equals 4x squared. Don't forget that you're squaring the number and the term over 0.100 minus x. I'm going to distribute this bottom part, 0.100 minus x, 0.100 minus x. So then when I do this, I am going to get 0.036 minus 0.36x equals 4x squared. I'm going to move everything over here because I need it to be 0 equals ax squared. So I'm just going to rearrange this to say 0 equals 4x squared. When I move this to the other side, the sign is going to change. So it's going to be 0 equals 4x squared plus 0.36x minus 0.036. Okay, so now we have it in ax squared plus bx plus c form. This is the form we need it to be in to be able to use the quadratic formula. Okay, so the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is ax squared plus bx plus c. So a in this case would be 4. B in this case would be 0.36. C in this case would be negative 0.036. That just comes from what you get when you put it in this format. So I'm just going to write that over here. A equals 4. B equals 0.36. C equals negative 0.036. So now I'm going to plug this in and solve for x. So x equals negative 0.36 plus or minus the square root of b squared, 0.36 squared, minus 4ac, so 4 times negative 0.036, all over 2a, which is 2 times 4. Okay, so when I solve, I'm going to get x equals 2 options. X, negative 0.36 plus this, negative 0.36 minus this. So let's see what the 2 options are. So I'm just going to solve for this term under the quadratic formula, under the square root right here. So 0.36 squared minus 4 times 4 times negative 0.0136, 0.342, I'm going to take the square root of that, 0.589. Okay, so now I'm going to say negative 0.36 plus or minus this. I did something wrong here. 0.36 squared minus 4 times 4 times negative 0.036 square root. That's right. So this term here underneath the square root is 0.84. So I'm going to say negative 0.36 plus 0.84 divided by 8, x equals that. Or I'm going to say x equals negative 0.36 minus 0.84 over 8. So let's see what that is. Negative 0.36 plus 0.84 divide by 8. In this case, x equals 0.06. Over here, I have negative 0.36 minus 0.84 divided by 8. X equals negative 0.15. So these are the two choices for my x using the quadratic formula. Well, x can never be negative because remember what we're essentially doing with x is we're solving for a concentration. We cannot have a negative concentration, so we automatically know that this one is wrong. So we know x equals 0.06. There will never be a situation where you solve for the two x's and both of them are possibilities. One of them will always be disqualified because it would give you a negative concentration, either because it's a negative number or when you plug it in, it would be negative. Okay, so again, the question asks, what will the equilibrium concentration of nitrogen dioxide be? Well, the equilibrium concentration of nitrogen dioxide is 2x. And I just said x was 0.06. So that must mean the equilibrium concentration of nitrogen dioxide is 2x, which means it's 2 times 0.06, which means it is 0.12 molar. So that's the answer to the question. So we had to go through all of that, use the equilibrium table, use the quadratic formula to solve for x, because once we know what x is, we can plug it back in to what is the equilibrium concentration, and then that will give us the concentration in molarity. So there is an example of using an equilibrium table to solve for molar concentrations at when we have to use the quadratic formula. The question did not ask for the molar concentration of the dinitrogen tetraoxide. It just asked for the concentration of nitrogen dioxide, but we can go ahead and solve for that too. N2O4 is 0.100 minus x, which would be 0.100 minus 0.06, which would be the same as 0.94 molar. Okay,